Good morning, my name is James Kinyan Dewey, BPI ID 5021617. I'm here today to show you how to do a combustion safety test within your CAS or your combustion appliance zone. The test consists of four different tests actually. Worst case depressurization, spillage, draft, as well as measuring undiluted CO. The first thing I want to do is figure out the worst case scenario for this place. To actually do that, I want to be able to see how the pressure is in here compared to what's going on outside. I want to do that naturally. I'm going to go around the house. I want to make sure that anything that can make this place more negative, the exhaust fans, dryers, anything that can suck air out of here, I want to make sure all that's either off or closed. On top of that, I want to make sure all these combustion appliances are off as well. I want to figure out what that pressure difference is just in a natural setting. So let's do that first. So far, this has been on for actually quite some time. I turned it off before the camera actually started rolling, as well as that combustion appliance. I went around the house, I made sure that everything was turned off, make sure this place is not more negative than it needs to be. That's all natural conditions. And now I'll figure out what the actual pressure is. To do that, I'm going to use a manometer. The manometer is going to tell me what the pressure is in here in relation to outside. So to get the pressure outside, I'm going to use a hose. I'm going to put the hose in, first I'm going to turn this on. I'm going to put the hose in reference. I want to know how this CAS is in the reference to the outside. So this hose I'm actually going to bring outside the CAS, outside the house, to the actual outside, the outdoors. Okay, and as I turn this thing on, if you notice, as soon as you turn on the manometer, it's already on Pascal, it's already on pressure, so I don't have to make any other adjustments to this thing. So it turns out in natural conditions, give this thing a chance to actually settle. It looks like we got roughly 0.2. So over here, I'm going to write our baseline, or just base pressure. In this case, is it still, actually it's still fluctuating. Looks like it's still roughly 0.2. So I'm going to put negative 0.2. So that's how this place is on natural conditions. Now I want to actually set up the house in the worst case. I want to make this house as negative as possible. I want to make sure the pressure in here, I just want to take into account how pressure in here changes. I'm going to put this down for a second. And I'm going to go around and I'm going to make sure all the dryers, all the exhaust fans, anything that makes this place more negative, including other rooms inside the house, I want to make sure all that is sucking air out this place, making it as depressurized as possible. I'm going to do that right now. So far, I turned on anything that can make this place more negative. I want to see what that difference is. So my new pressure differential looks like it's at 0.9 or 0.7. It's going to fluctuate for a bit. Looks like 0.8 or 0.5. It looks like an average of 0.7. So I'm going to put that as my depressurization. So worst case was 0.7. So my worst case is 0.7, my base was 0.2. I want to figure out what that difference is, by how much did it change. So 0.7 minus 0.2, that difference is 0.5 pascals. So what does that mean? To actually figure out if this is good or bad or what, I need to refer to a chart on the BPI standards. Let's see what that chart says. Keep in mind, throughout this whole time, I'm checking my, actually, all the combustion appliances are off, so I'm not going to check that just yet. There we go. So on page 14, there's a table that says CAS depressurization limits. This lets me know how negative can this place be before it starts getting into a dangerous situation. So in order to figure this out, I need to look around and figure out what kind of condition am I in. So I see a combustion appliance here, my DHW. I see that it's atmospherically vented, check out how it's open. And the flue pipe is actually connecting to another combustion appliance, which is also atmospherically vented. So there's two commonly vented combustion appliances in this CAS. That being said, I'm looking at line number 2, natural draft boiler furnace commonly vented with a water heater. So our limit is -3 pascals. When we ran our test, it looks like we got -0.5. So we're actually in good standing. We actually passed the worst case scenario. So we can continue with the rest of our tests under the worst case. So we got -3 as the limit. We actually got negative, I should put here, it's a negative number of course, -5. So we're still good. We're not nowhere near -3 pascals. Let's continue the test. So the next part of the test is spillage. When I turn this thing on, I want to see if those flue gases are actually coming out. So right now I just fired the DHW up. Now if you notice, I'm turning on the combustion appliance with the least amount of BTUs first. And where am I testing on this thing first? So right now, this thing's going to start spraying out some gases. I'm going to wait about 60 seconds. So far, about 15 have passed. Now, as that's happening, I'm going to use, you can use a mirror. In this case, I'm going to use my smoke stick. Now, keep in mind, as the combustion appliance is running, I'm going to start periodically checking my ambient CO detectors to make sure it's not either 9 or 35. If it's 35, then of course I have to vacate and take the homeowners with me. So far, looking pretty good on ambient CO. We're still okay. I'm going to use a smoke stick. I want to see if those gases are actually coming out. Remember, the time is 60 seconds I'm looking for. So as I'm doing this, I want to see if the smoke is actually being drafted up the flue pipe. Alright, so I'm still counting seconds in my head. I'm approaching about a minute. And so far, it looks alright. So far, it looks like those gases are still going up. Actually, let's make sure. Let's make absolutely sure. Okay. I don't see those gases coming back out into my face. It looks like we're good. Looks like we passed the spillage. If this thing kept spilling out after 60 seconds, that's called backdrafting. That's a bad situation. That means we failed the spillage test. So right now we're looking pretty good. Right now we passed. So the next test after this is what they call the draft test. I want to figure out if in here, some flue pipe is very negative. If all the air in here is helping pushing that air up and out the flue pipe. To do that, once again, with the manometer and see what's happening inside that flue pipe. So I'm taking the same manometer, and this time I want to figure out what's happening in here compared to out here. So now the cast is my reference point. I'm going to stick my hose into the input. Right, I'm going to use the input side of side A, and I'm going to stick this into the actual flue pipe. Now keep this in mind, when I stick this in, the first thing I'm going to do is connect the metal hose so I don't actually melt the melt the hose. The second thing I want to do is make sure that the hole I put this thing into is away from the first bend. So I don't have it very close to the diverter. So over here, after my first bend, about a foot away, I'm going to put my hose right here. So the idea is I want to figure out what that pressure differential is. Looks like 0.6. We're not covering the bottom hose because that's up here to us. But it looks like 0.3, 0.4. And it's fluctuating. Actually, it's climbing. Keep in mind, this is going to keep fluctuating until this thing actually reaches steady state, so it stops actually fluctuating. Steady state's roughly 5 to 10 minutes after you turn this thing on. So in roughly 5 minutes, I'm getting about, looks like 1.2, 1.1. Oh, it's still fluctuating. So it's like roughly 1.5. So what does this number mean? I'm going to take this number, I'm going to write this number down. I want to see if this is good or if this is bad and compare it to a table. So for draft, I actually got, I'm going to write draft here. I got 1.5. Let's keep that number. So how do we compare this? Let's look at the standards. So on the standards, we're going to look for our draft, acceptable draft ranges. That's on page 10. So it looks like it depends on the temperature that's outside. Last time I checked, temperature outside is 80 degrees. So according to the chart, it's more than 10, it's less than 90. We're in this range. So in this range, there's an actual formula you have to do to figure this kind of stuff out. The outside temperature divided by 40 minus 2.75. The outside temperature was 80 degrees. I want to divide that by 40. That'll give me 2. So then 2 minus 2.75. Oops, sorry. 2 minus 2.75. That'll leave me with negative 0.75 pascals. So negative 0.75, and my draft was actually 1.5. So my draft, oh, I'm sorry, I forgot to mention this is a negative number. I apologize. So it looks like in here is more negative than it needs to be, and that's actually a good thing. The more negative it is inside here, the more those gases are going to try and draft out. So according to my table, I should have no less than negative 0.75. In here I got 1.5. I'm good. I am above beyond. In this case, this is a good thing. The more negative this is, the happier we are. So far we passed the worst case, we passed draft, we passed village. The next step is the CO, the undiluted CO. That's what gets generated deep inside the combustion appliance. Before I continue, I want to check my ambient CO. We are still good, nowhere near 9, nowhere near 35, so we can still continue. The next step is the combustion analyzer. Now keep in mind, when you turn this thing on, you should turn this thing on outside, so it has a chance to actually zero out. Once it zeroes out, you can actually start selecting what needs to be done. So give me one moment, and I'll actually turn this thing on. I'm going to step outside and stick this thing outside to make sure I get a good clean reading. Alright. You give this thing about 60 seconds, and we shall begin. Actually, I'll turn on the light so you guys can actually see the countdown. So once again, just to be sure, I'll check my ambient CO. You want to check this thing constantly to be absolutely sure that you're not in a dangerous situation. Or in the worst case, this thing is firing, you want to be absolutely sure. Now remember, you want to wait for this thing to reach steady state. So far it's been over 5 minutes, so I can actually start testing this thing now. About 5 seconds left, and we shall begin. Alright, so the first thing I want to do is select the actual fuel type. For this particular combustion appliance, the fuel type is natural gas. So on the menu, hit menu, hit fuel type, natural gas. Cool. Now I'm going to hit run. I'm going to stick this thing down the throat of the combustion appliance. This is what we call a diverter, right? Right above the flue pipe, where the flue gas is mixed with the actual ambient air. I want to stick this actually past that diverter, right next to that baffle, and stick this thing in to get a good reading of undiluted CO. So I'm going to hit run, this thing's going to make some noises, and I want to see what kind of reading I get. So keep in mind, when you're doing this test, you want to put the probe on both sides of that baffle past diverter. You want to go inside and get a good reading of the undiluted CO. So check this out. If you guys can see this, it looks like we're at 17, 18 parts per million. I'm going to write this number down just so we have it on, just so we have it. Alright. 18 ppms, or parts per million. So now we're at 20, so I'm just going to write that down. Now I want to check the other side as well. In some cases, you do want to drill an actual hole into the diverter to get a good, solid, to be sure it's in there properly. For these purposes, I'm not going to actually drill a hole. We don't have any of this tape on us. Try to do some finesse. Alright, once again, I want to get a good reading and see how much undiluted CO this thing's actually generating. So on this side, I got about 14, 15 parts per million. So I'm going to record these numbers. I'm gonna turn this off. Save batteries. Still checking my ambient CO, just be on the safe side, of course. So what does all this mean? So far we ran 4 tests. Our worst case, we passed, the spillage we passed, the draft we passed, and the actual CO this thing's producing was roughly in the 20 range. Let's see what it tries to say about this. Where's my chart? So the thing, chart I'm going to refer to is the combustion safety test action levels. This is page 13 of the standards. So we got about 20. So I'm going to the range of 0 to 25 ppms. That's pretty much our range what we got. It looks like we've passed the spillage and the draft test. So I'm going to look at this first line. That's what our results say. And it says retrofit action, proceed with work. I can continue working. So far we're doing pretty good. So keep in mind, this is not the only combustion appliance. This is actually tied into another combustion appliance. It's actually coming vented with a boiler. So I'm going to run those same tests, the spillage, the draft, as well as the CO, the undiluted CO, on the boiler as well. While this thing is running, I want to see if I get good readings. And of course, depending on readings I get, I'm going to refer to my combustion safety action level charts. Let's move on to the boiler. This thing's already running. Let's do spillage. Where's the smoke still? Oh. Okay. So this thing is actually starting to turn on, right? I have to wait 60 seconds. I'm going to test the spillage on this particular unit. Now, if you notice on this unit, it's a bigger unit, but it's still atmospherically vented. So what's that mean? That means that beyond the diverter, which is this thing, is actually hollow. So to figure out if this thing's actually drafting or not, I don't know if you can still see me. So far I'm still counting seconds in my head, that same number of seconds. And when you smoke stick, and believe it or not, the draft hood is actually down here. So here's where the diverter is at. And pretty much I want to see if any smoke being blown into my face or is actually being sucked in. It's a good thing this thing comes with a light so you can actually see what you're doing. So remember, you're going to wait until it gets up to 60 seconds. And I'm still counting seconds. We're almost there. So far, this thing is not spilling back into my face. This thing is passing the spillage test. Looks like we're good. Alright. So once again, I still want to check the ambient CO inside the room. I want to make sure this is still a safe situation. So every once in a while, I'm checking for those numbers. We're way below 9, and we're okay. So the next test is the draft. I want to make sure inside here is still negative. I'm sucking those gases out. To do that, once again, I take the manometer, and I'll do the same setup I did before with this combustion appliance. I'm going to take the hose, I'm going to put it in inputs, and I'm going to reference the actual air in the cast. I want to see how negative it is inside this unit. So once again, right past the elbow, up about a foot, that's right here. Looking for us is already a hole present, so I'll stick this in. And I want to see how negative it is inside this unit. So I don't know if you guys can see, I don't know if you guys can see that far ahead. I'm getting roughly it's like -1. It's rounding out to about -1, more or less. 1.2. Alright, so once again, I'm going to write down that number, right? -1, -1.2. That was the range I got. So I'm going to go back here. I don't know if you can see me here. And my draft here, I got roughly 1.2. So once again, how I know that's good, how I know that's bad, I refer to my chart. Now remember the chart. Let me grab that. So remember the chart had this formula, right? The temperature outside, that by 40 is the same exact chart we use for this. Now we've already done this equation, you already know what the number we're looking for. The number we're looking for, if you remember back to here, was -0.75. This combustion appliance inside the flue pipe gave us a 1.2. So 1.2 is more negative than our requirement of -0.75. So even this combustion appliance is still working okay. So this combustion appliance is working properly. It looks like we're still good. So the next, that was spillage passed, draft passed. The last thing that we're going to do is the undiluted CO. So the undiluted CO, I'm going to take my combustion analyzer and I'm going to test literally inside the combustion appliance. Thank you. So the same setup, check it out. Black pipe, I know automatically this thing is natural gas. So I'm going to select natural gas. Oh yes, right, so we're good to go. So remember, I want undiluted CO. What does that mean? Undiluted CO, what does that mean? That means I'm going to stick this inside the, past the diverter. And so far it's been past steady state, so I can initiate this test. I hit run and I just wait to get a reading for the undiluted CO of this combustion appliance. So look at 22 parts per million. 22. Alright. Sorry guys. Try not to touch anything. Alright. So we got 22 parts per million. We passed worst case, we passed spillage, we passed draft, we got 22 parts per million for that combustion appliance. So what does that mean? Well, so far it's pretty much the same thing as our DHW. This one had roughly 20, this one had 22. So if I refer to my action level to get a clear idea of what to do, I'm almost in the same spot, right? 0 to 25 ppms, that's what we got for our boiler. We passed spillage, we passed draft. So our retrofit action, we can still proceed with our work. We can still do what we got to do. So that concludes our combustion safety testing for a combustion appliance zone that has 2 combustion appliances that are commonly vented. Thank you for your time.